The question here is, the sun rotates around its center once in 27 days. What will be the period of revolution if the sun were to expand to twice its present radius without any external influence? So this is the question of conservation of angular momentum. This is the question of conservation of angular momentum. So I1 omega 1 is equal to I2 into omega 2, omega, that is moment of inertia into your angular velocity. And so here this is a question of conservation of angular momentum. The moment of inertia of a sphere, that is the moment of inertia moment of inertia of a sphere that is equal to 2 by 5 m r square. This is the moment of inertia of a sphere, and omega 1, that is equal to 2 pi. By time period it is your 27, it is given to you, and we have to find omega 2. So 2 by 5 mi 2 by 5 m r square into 2 pi by 27 is equal to 2 by 5 m. Here your radius becomes twice r, it is given to you 2r the whole square into 2 pi by omega 2. We have to find it out. Now if you solve this, I am not going to go in details, but if you solve this equation, you are going to get here see m and r square will cancel out, 2 pi 2 will cancel out. So when you solve this, you are going to get omega 2, that is equal to 27 into 4, that is equal to 108 days. You are going to get 108 days. So this is your solution. Now I am going to the next question. Your next question is here. The next question is, a pipe at both ends has a fundamental frequency f in air. The pipe is now dipped vertically in water drum to half of its length, the fundamental frequency of the air column. So here at first this is I am drawing the picture. This is an open pipe. So here and another. This is the N node, and here this is x is equal to 0, and here this is x is equal to L, that is the length of the pipe, and node will be at L by 2. So your L will be equal to lambda 1 by 2, and your frequency will be equal to f. Your frequency will be f. Now here again your frequency that is equal to v by lambda 1, and that is lambda 1 that is equal to v by 2L, v by 2L, lambda 1 that is 2L. Now when it is dipped in water, your figure becomes like this. When it is half dipped in water, so your figure becomes like this. It is dipped in water. Here up to half it is filled with water. Here it is filled with water. So your length becomes L by 2. L by 2. So your L by 2, that is equal to lambda 1 by 4, and lambda 1 by 4. So here your lambda 1 is equal to 2L, twice L, and twice L. So your frequency, that is equal to F. Frequency will be F. So your option is your second option is option 2. Your option is 2. Here your option is 2. Lambda 1, this is 1. Lambda is 12, so frequency will be F, because F. So again here you see that F is equal to V by 2L. Frequency will be the same. So your option 2 is your correct answer. Now I am going to another question. An electric dipole. Here there is an electric dipole. With dipole moment, this is aligned in the direction of uniform electric field of magnitude 4 into 10 to the power of 4 Newton per Coulomb. The dipole is then rotated through an angle of 60 degree with respect to electric field. The change in potential energy of the dipole. So your change in potential energy is equal to U 60 degree minus U 0 degree. So here U 60 degree, that is equal to minus dipole moment into electric field cos 60 degree minus P E cos 0 degree. So now if you place the value of the dipole moment, that is equal to minus 5 into 10 to the power of 6, and electric field, that is into 4 into 10 to the power of 4, cos 60 degree, that is equal to 1 by 2, minus plus, and again 5 into 10 to the power of 6 into 4 into 10 to the power of 4, cos 0 is 1. So from here you get, when you calculate this, you are going to get half. So half plus 1, this will be half into 50 into 10 to the power of 6 into 4 into 10 to the power of 4. So 2s are and 10, this is 10 to the power of minus 6, this is 10, sorry, the minus 6, 10 to the power of minus 10 to the power of 10 to the minus 6. So here this is 2 cancels 10 to the power of 4. Here again, then this is minus 6. So 10 to the power of 5, 10 to the power of 5, so here this is 10 to the power of 5, so this is 10 to the power of minus 1, 10 to the power of minus 1, this will be 10 to the power of minus 1 joules. There is some problem here. your uh, electric field of magnitude here, this must be 10 to the power of 4. This is 10 to the power of 4. If this is 10 to the power of 4, then minus 1 by 10, that means 0.1. 0.1. Here this must be 10 to the power of 5. This must be 10 to the power of 5 electric field. Then only 10 to the power of 5. This must be 10 to the power of 5. So here this is 10 to the power of 5. And this is 10 to the power of 5. And again here this is 10 to the power of 5. So this is 10 to the power of 5. So this becomes so this will be 10 to the power of minus 6, 10 to the power of 5. This will come out to be 1 joules. This will come out to be 1 joules. Here this is 4 into 10 to the power of 5. Here this will be electric field is 4 into 10 to the power of 5. 10 to the power of 5. So then it comes out to be 1 joules. That is potential energy at 60 degree minus potential energy at 0 degree. This is the change in potential energy. So when we calculate it, it comes out to be 1 joules. Now I am going to another question. 5 joules respectively. On applying brakes, car A stops after 1000 meter and car B stops after 1500 meter. If an FA and FB are the forces applied by the brakes on car A and B respectively, then FA by FB is. Now here you see that your kinetic energy for car A, that is 100 joules, it is given to you, and kinetic energy for car B, that is 225 joules, it is given to you. For car A, because the final velocity is 0, v square is equal to u square minus 2as, because retardation is taking place. Your final velocity is 0, so this will be u square is equal to 2as. Now I am going to multiply both sides by half. Let this be a1 for car A. This will be a1, this will be a1. So half m u square is equal to half m 2a1s. So here 2 cancels out. This becomes equal to fa into s. Your s is 1000 meter. Your s is 1000 meter. Similarly for car B, this is u square is equal to 2a2s. So again we multiply by half. So your let me do one thing here. Let me do one thing here. So this is the kinetic energy. So kinetic energy of car A, it is 100 joules. It is 100 joules. That is equal to FA into 1000. Similarly for car B, it is 225 joules. That is equal to FB into 1500. Now we divide this two equations. We are going to get 100 by 225 is equal to FA into 100,000 divided by FB into 1500. So now if you solve this, you are going to get FA by FB, and that will be equal to 2 by 3. If you solve this, you are going to get this equation. This is the result. So now going to the second question. And now your second question is, there are two identical surfaces of equal length L inclined at 45 degree with the horizontal. One of them is rough. One of them is rough. One of them is rough and other is perfect. A given body takes 2 minutes at as much time to slide down on the rough surface than on the smooth surface. The coefficient of friction between the object and the rough surfaces. The body takes takes two times as much time to slide. Now here it's an inclined plane. This is an inclined plane. A body here. Now here your weight, that is vertically downward, that is mg, and here this angle is 45 degree. Now it has two components. One is mg cos 45 degree, and another it is this component, that is mg sin 45 degree, and here this is your friction F. This is 45 degree. Sine 45 degree. Now here for the first case, since it is a smooth, we consider it as a frictionless. So mg sine 45 degree is equal to ma1. This is the force. And for second case, let us take mg sine 40, because it is a rough surface, minus frictional force, that is equal to ma2. Now from here we get a1, that is equal to a1 is equal to g by root 2. From here we are getting a1 is equal to g by root 2. Now I am going to find a relation between a1 and a2. I am going to find a relation between a1 and a2. So here you see that both travels the same distance, and initially they are at rest. So taking this formula, S is equal to u t1 plus half a1 t1 square a1, and now it is given that this is and S is equal to u t2 plus half a2 t2 square, but it is given that the time taken by the rough surface, this is for rough, this is for smooth, and this is for rough. Now here it is given that the time taken by the rough surface is 2 times more than that of the smooth surface. So this will be equal to S is equal to u t2 plus half a2 and twice t1 the whole square. Both are traveling the same distance, and initially they are at rest, so initial velocity is 0. So from this we get the relation half a1 t1 square is equal to half a2 4 t1 square. So here we get that a1 is equal to a2 4. So your a2 4. So a2 will be, for this is 4, this is 4, 2 square 4. So your a1 by 4 is equal to a2. This is the relation we get here from between a1 and a2. We know that a is g by root 2, so your a2 will be g by 4 root 2. Now you see here, that is for rough surface we got the acceleration, and we know the relation, that is mg sine 45 degree is minus f, that is equal to m a2. Your mm cancel out, so this is g by root 2 minus f, this is equal to m a2, your g by 4 root 2. So oh sorry, this m cancels out, this m and m, this cancels out. So here we get that g by root 2 minus g by 4 root 2 is equal to f, so if you f and g common, 1 by root 2 minus 1 by 4 root 2 is equal to frictional force, that is equal to the normal reaction, that is equal to the normal reaction. This is mg, and your frictional force is equal to the normal reaction, and this is 45 degree normal reaction. So this is equal to nu k into normal reaction is mg cos 45 degree, that is equal to 1 by root 2 mg cos 45 degree, that is equal to root 2 here. Oh sorry, here the m doesn't cancels out. M, and this is equal to m, so here this is also m, and again here this will be m. So your mg cancels out, and cancels out, so here this will be 1 by root 2 minus 4 by root 2, that is equal to nu k 1 by root 2. So here when you solve this, this is 4, this is 4. So when you solve this, 1 by root 2 common, 1 by root 2 common here, 1 by root 2 cancels out, so 1 minus 1 by 4, so this will be equal to 3 by 4 is equal to nu k, and this is equal to 3 by 4 means 0.75. So your option D is your correct option. Now I am going to the another question, that is here an electron of mass, this is given to you, and moving with a speed of c by 100 is projected in a magnetic field. This magnetic field is given to you, Tesla, perpendicular to the direction of which to an uniform electric field together with a magnetic field, so that electron does not deflect. So does not deflect from its path. So which option is correct? So now first of all I am going to find out the electric field, because here I am going to find out the electric field. So here I am going to find here V is equal to electric field by magnetic field. Now your V is C by 100, and that is equal to E by B. So B is given to you, so C, that is 3 into 10 to the power of 8 by 100 into B, it is given to you, that is 9 into 10 to the power of minus 4 is equal to E, and when you calculate it, you are going to get 27 into 10 to the power of 2 V, that is equal to E. Now E is the electric field is perpendicular and of magnitude 27 per meter, perpendicular magnitude, parallel E is parallel, both are magnitude is 20. Your first option, your second option, your second option, E is perpendicular to B, and its magnitude 27 into 10 to the power of 2. It is 10. If you calculate, you are going 10 to the power of 2. So your option 2 is the correct answer. Now going to the next question. Your next question is the ratio of wavelength of light absorbed by hydrogen atom when it goes from n is equal to 2 to n is equal to 3, and from n is equal to 4 to n is equal to c. We are going to use this formula we are going to use this formula 1 by lambda 1, that is and RH, this is Rydberg constant, that is bracket 1 by 3 square minus 1 by 2 to 3, 1 by 2 square, and another 1 by lambda 2, that is equal to RH, Rydberg constant, bracket 1 by 6 square minus 1 by 4 square. Now if you are going to calculate this, 1 by lambda 2 sorry 1 by lambda 1, you get this 1 by lambda 2, if you solve this, you are going to get minus 5 by 144 by minus 5 by 36. So this will be equal to lambda 1 by lambda 2, that is equal to 36 by 144, and this comes out to be 1 by 4. So your ratio is 1 by 4. Now I am going to the next question. This is of an AC current. This is AC current and an AC supply of 220 volt at 50 hertz. This all resistor of the capacitor and the resistor and the reactance of the capacitor and the reactance of the inductor is given to you. So you have to find the current. So this is a simple question. I is equal to V by root over R square plus XL minus XC the whole square. This is plus XL minus XC the whole square. Now if you place the value, that is 220 by root over 20 square plus 45 minus 25 the whole square. Here you are going to get the result will be 220 divided by 45 20, so this is equal to 20 root 2, and this will be equal to 11 by 1.414. So this comes out to be 7.8 ampere. And tan theta, your tan theta that will be equal to XL minus XC by R. So this will be equal to 20 by 20 is equal to 1. So theta will be equal to 45 degree. So your option 2 is the correct answer. Now I'm going to another question. Another question. The electric field in a electromagnetic the electron in an electro in a plane electromagnetic wave is given by this. It is given to the expression for the corresponding magnetic field. Okay, so again we are going to use the formula V is equal to E by B. We are going to use the formula V is equal to E by B. So from here we are going to calculate the magnetic field. Your magnetic field will be E by V. So E, it is given to you 60 here, 60 divided by velocity of the light, that is 3 into 10 to the power of 8, because it is an electromagnetic wave, which comes out to be 2 into 10 to the power of minus 7 Tesla. So Tesla, so your answer will be By is equal to 60 sine 5 into 1.5 into 5x 5x plus 1.5 into 10 to the power of 9t Tesla. So this is your answer. Now I am going to another question, that is here. This is this question I have selected this because I have found that the answer is d2y by dx square is equal to rho g by s into s y. I have made a dimension analysis for this. From the dimension analysis, this part, that is rho density, that is m l to the power of minus 3 g l t to the power of minus 2, and your this s, that is surface tension F by L, that is m l to minus 2 by L, and your here this y, again length, that is L. I made a this dimension analysis. From this dimension you get L is equal to L to the power of 0, and here again tan theta angle, that is for tan theta, your L is 0. So tan theta for angle, your L is 0. So here I find that it is dimensionally consistent. I found that it is dimensionally consistent. So I have selected this, the option 2, your option 2. I have selected the option 2. Now my next question here is that my next question is let me see. Oh, 1 minute. This is my next question. That is the radius of Martin orbit around the Sun is about 4 times the radius of the orbit of the Mercury. The radius of Martin about Martin orbit around Sun is about 4 times the radius of the orbit of Mercury. The Martin year is 687 Earth days. Then which of the following is the length of 1 year of Mercury? This problem is solved by the Kepler's law. This problem can be solved by this Kepler's Kepler's law. This can be solved by this Kepler's law. This is T square is proportional to R cube. By the help of this theory, we can solve this problem. I have taken this T, M and R, M. They are the orbital period. Be the orbital, be the orbital period, and radius, be the orbital period and radius of Mars, and small letter Tm and Rm be in the orbital period, be the orbital period and radius, be the orbital period and radius of Mercury. So here Martin time period is 687. It is given to you. So Tm by T Mercury the whole square is equal to R radius of Martian by radius of this Mercury, radius of Mercury the whole cube. It is given to you from here. Now I am going to solve it, because here it is given that the radius of Martian orbit is around the Sun is 4 times the radius of the Mercury. So here, and time period of this orbital period of this Martian, it is given to you, that is 687 Earth days. So this will be 687 divided by Tm the whole square is equal to, and this is 4Rm by Rm the whole cube. Now if you solve this, you are going to get Tm is equal to 85.8 Earth days. So this will be equal to 88 days. This will be equal to 88 days. Now my next question is this. This is you can directly state that which type of gate will be the result. This will be a NOR gate. This will be a NOR gate. This will be answer will be a NOR gate. Now I am going to the next question. de Broglie wavelength. De Broglie wavelength of an electron. It is of an orbiting in n is equal to 2 state of hydrogen is close to. So your de Broglie, we know that our de Broglie wavelength, that is equal to de Broglie wavelength, that is equal to h by mv. So here your lambda will be equal to h by mv. Now we know that mvr is equal to nh by 2 pi. So your mv is equal to sorry nh by 2 pi r. So by 2 pi r. Now we place the value of mv here, so your lambda will be equal to h by, this is h by n h, mv value nh by 2 pi r. This is the lambda. Now so your lambda will be equal to, so your lambda will be equal to this is not 4 there, this is 1 minute, let me rub this is h, this is h, this is h. So here h cancels out and lambda will be h cancel out. So here this will be 2 by n, and we know that n is equal to 2. So your n is equal to 2, so lambda will be equal to 2 by 2. 2 by 2, that means 1. So that will be pi r. This will be your, and your radius r will be equal to close, this is, there is a relation close to a naught, so this will be equal to r square into a naught, so this will be equal to r square. So this will be this comes pi r n square, sorry, this is r is equal to, this is n square. So n is equal to 2 square, that is 4 into 0.052. So this comes out to be 0.208. This will be n square, because here r not. So here your lambda will be 3.14 into 0.208. So this comes out to be 0.6531 nanometer. So 0.67. So your option 2. Now I'm going to the second question. Your second question, you have to find the error. So this is very easy to find the error. This is very easy. 100, direct 100, del p by p is equal to 3 into del a by a into 100 plus 2 into del b by b into 100 plus del c by del c by c into 100 plus 1 by 2 del d by d into 100. So this will be equal to 3 into 1% plus 2 into 3% plus c 1 into, that is 2% plus 1 by 2 into 4%. So this comes out to be 3 plus 6 plus 2 plus 2. So this is equal to 30%. Now I am going to the next question. This is your next question. Here, first of all, we know that moment of inertia of a sphere, that is equal to 2 by 5 mr square. We know that. So we know this. Now for the smaller sphere, we are going to find the moment of inertia for the smaller sphere will be this one, 2r. So r square. It is this is for smaller sphere. And this is for smaller sphere. Smaller sphere. Smaller sphere, and it is the moment of inertia is for this smaller sphere is through the center, through the center. Now moment of inertia. Now we are because we have to find out moment of inertia about y-axis, because you have to find out the moment of inertia about y-axis. So I am going to take the help of parallel axis theorem. I am going to take the help of parallel axis theorem, because in the question it is given that you have to find the moment of inertia about y-axis. This is the moment of inertia about the center of the sphere. This is the moment of inertia about the center of the sphere. Now we have to find about the y-axis, so I am going to use the parallel axis theorem. So this moment of inertia will be equal to how much? That is 2 by 3 mr square plus your mr square. This distance is from the y-axis, it is r. So here this will be equal to, you are going to get 5 sorry, this is not 3, this is 5, because the moment of inertia of a sphere is 2 by 5. So this is 5. Now we are going to get the result 7 by 5 mr square. This is the result we are going to get, the moment of inertia of this smaller sphere about the y-axis, because you have to find the moment of inertia of the moment of inertia of the about y-axis. Now I am going to find the moment of inertia of the sphere with radius 2 of radius 2r. This is the radius 2r. So here we see that here we are going for this calculation. One thing I have mixed here, that I must take this this m. What is this m? Your m mass will be here. Your mass will be rho into 4 by 3 pi r square. Your mass will be this. Here your mass will be this, and for the smaller sphere your mass will be this. Now for this whole calculation is for smaller sphere. Now for larger sphere, your mass will be m, that will be equal to rho 4 by 3 pi 2r the whole square, and this will be 4 times this. So let us take this large, let us take L, and this is small, so let us take S. So let us take this S. So this is, let us take this S, let us take this as smaller sphere, as for smaller sphere, and this is large. So it has been found that it is equal to 2 to the 4, 4 to the 4, 2 to the 4, 4 sorry 2r, sorry 2r, 4 by 3, again I have made a mistake here, sorry, this is volume of the sphere is 4 by 3 pi r cube, and here this will be also cube. So you will find that here the relation here is 8 times your mass of the smaller sphere. So for this larger sphere there is no problem. Moment of inertia about y-axis. This is moment of inertia about y-axis for the smaller sphere. For smaller sphere I have to take the help of parallel axis theorem, but for larger sphere, that is moment of inertia, that will be equal to this is equal to we know that it is a moment of inertia of a sphere is 2 by 5, and mass of the larger sphere, that is equal to 8 ms, mass of the larger sphere, and your radius is 2r the whole square. So this comes out to be 64 by 5 m s r r square. It comes if you r square, this comes out to be this. So the moment of inertia of the, this is for the larger sphere about y-axis, this is the moment of inertia of the smaller axis about y-axis. So the moment of inertia of the remaining, moment of inertia of remaining sphere, remaining sphere, that will be equal to 64 by 5, 64 by 5 m large, that is ms r square, minus 7 by 5, this is for smaller ms r square. If you solve it, you are going to get 57 by 5 ms r square. Now if you find the ratio, I small by I large, if you find the ratio, you are going to get I small is 7 by 5 and I large is 57. So your ratio will be 7 by 57. This is your answer. Now I'm going to the next question. Your next question is this. Here your answer will be directly according to what we have to find. We have to find magnetic moment. You have to find the magnetic moment. Your answer will be your magnetic moment. Your magnetic moment. Your answer will be here. Your answer will be EH by 2 pi m. This will be your answer. Now I am going to the another question. Here two cities are connected at are connected by regular bus service with a bus leaving in either direction every t times. That means your time period is given to you. Every t times your time period, it is given to you, t minute. A girl is driving a scooty with a speed of 60 km per hour in the direction x to y. Notice that a bus goes past her every 30 minutes in the direction of her motion and every 10 minutes in the opposite direction. So here the direction is from, here you see the direction is from x to y. Direction is from x to y. So relative velocity of the bus with respect to girl is equal to Vb minus Vg, that is equal to Vb minus 60 So girl moving in scooty. Now your distance traveled by bus, this is the distance traveled by bus will be distance distance traveled distance traveled by bus will be this will be VB minus minus 60 into 0.5. This is the distance traveled by the bus. This is for same direction. This is for same direction. This is for same direction. Now for opposite direction, for opposite direction, your VBG bus with respect to girl will be VB plus VG. So and your distance 30 minutes 30 by opposite direction over 10 minutes. In opposite direction it is 10 minutes, in the same direction 30 minutes, 30 by 60, that is equal to 1 by 2, therefore it is 0.5 hour, therefore it is 0.5 hour. Now in opposite direction your distance traveled by the bus, that will be equal, distance traveled by the bus will be VB, that is VB plus VG, VB plus VG is, that is girl, that is 60, and in opposite direction is 10 minutes, 10 minutes means 10 by 60, that is equal to into 1 by 6 hours. So your both this distance are the same, so here it will be VB minus 60 into 0.5 is equal to, that is VB plus 60 into 1 by 6. So if you calculate this, you are going to get VB, you will get VB is equal to 120 km per hour. If you calculate this, you are going to get VB is equal to 24 km per hour. Now your t minutes, so VB into t, that will be equal to VB into your time period is t minutes, so into t by 60, this becomes hours, so this will be equal to VB plus 60 into 1 by 6, 6 here cancels out, so this will be VB, that is VB, it is 120 into t by 60, that will be equal to VB, that is 120 plus 60 into 1 by 6, so your time period will be t will be equal, if you calculate it, your time period will be 15 minutes, and your VB is VB is 120 km per hour, so your option is 4. Your option is 4. Now I am going to the another question. This is the intensity polarization. So here it is, I am writing directly, I will be equal to I naught cos square 22.5 into cos square 67.5, 90 minus 22.5, that is 66.67.5. So this is equal to I will be equal to I naught cos square 22.5 into sine square 22.5. So this is I is equal to I naught by 4 into I naught by 4 I naught by 4 into 4 cos square 22.5 into sine square 22.5. So this will be equal to I naught by 4. This will be 2 sine theta cos theta, that will be sine 45 degree to the whole square. So this will be equal to I naught by 4. This is equal to 1 by root 2 the whole square. So this will be equal to I naught by 8. So this is your third option 3 is your answer. So option 3 is your answer. So this is your second phase. I have dealt with the second phase questions.